Hello everyone, welcome back to Partners DSA. Let's try to solve the problem walking robot simulation from lead code. So the problem statement says a robot on an infinite xy plane starts at point 0, 0 facing north. The robot receives an array of integers commands which represents a sequence of moves that needs to execute. There are only three possible types of instructions the robot can receive. -2 turns 90 degrees left, -1 turn 90 degrees right, and if any value k which is between 1 to 9, move forwards k units, 1 unit at a time. So some of the grid squares are obstacles. The ith obstacle is at grid point say xi, yi. If the robot runs into an obstacle, it will stay its current location and move on to the next command. Return the maximum squared Euclidean distance that the robot reaches at any point in its path. So maximum squared Euclidean distance means if the distance is 5, then it's square. That is 5 into 5, 25. So here the north means plus, like if we are in the y direction, the north means plus y, east means plus x, south means minus y, west means minus x. And also one another note is like there can be an obstacle at the very starting 0, 0 itself. At that time, like the robot will ignore this obstacle until it has moved off the origin. However, it will be unable to return to 0, 0 due to the obstacle. So it means like if it's the first scenario, like we are starting, and even if there is obstacle at 0, 0, we don't care about that. We will just execute the command and we'll start move forward. Now after some point of time, if the command, after following the command, we reaches back to this 0, 0, that won't be possible because 0, 0 is having an obstacle. So that won't be possible. We will be just stopping nearby to that obstacle. So let's take an example. So here 4 minus 1 3. So let's say this is our plane. This is north, this is east, this is west, this is south, and this is west. Now our first example, 4 minus 1 3. So we start at 0, 0 and we are facing north. So what happens means at first our the command is 4. So if the command is anything between 1 to 9, we will just move forward k units, 1 unit at a time. So if it is 4, we will start moving 1, then 2, then 3, then 4. It will be not jumping from 0 to 4, but it will be like moving 1 unit at a time. So the next command is -1. So -1 means like now we will be rotating towards the right. So now like we were moving the y-axis. After rotating to the right, now we are facing this east direction, and that will be like moving the x. It means like plus x direction. So now we will start moving our x-axis, which is at 0. So next one is 3. So we will be moving 3 points. So 1, 2, 3. So this will be our final point, 3, 4, and that's it. Like that's it with this particular example. So here the points are 3 and 4, and the Euclidean distance will be 3 square plus 4 square, which is equal to 3 square is 9 plus 16, which is equal to 25. So here our answer will be 25. Similarly, let's take one more example which have some obstacles. Okay, so here like this is our commands 4 minus 1, 4 minus 2, 4, and there is an obstacles at 2, 4. So let's see how this works. Now we start at 0 0 facing north and our command is 4. That means if it is north, we will increase our y direction. So we will increase our y direction to 4. 1, 2, 3, 4. Now the next command is -1. So we will just return or turn to the right. Now we will be facing east. In that case, we need to increase this x. So how much? It says 4. So we start moving one at a time. 1, 2. But if you see, like there is an obstacle at 2, 4. So we can't move to 2, 4. This is having an obstacle. So we will just stop at 1, 4. That happens when there is an obstacle. Now the next one is turn left. So from here we will just turn left. So we were at east. Now after turning to the left, we will like face the north again. So from north we will move 4 up again. So we were at 4, we will again move up 4 positions up and we will reach 8. So the final point will be, if we make a point here, it will be 1, 8. So here the Euclidean distance will be 1 square plus 8 square, which is equal to 64 plus 1, 65. If you check the answer is 65. So the moment we see an obstacle, we just need to stop before that obstacle. Otherwise, we can just move on with whatever the command that we have. So what are our possible solutions that we can think of? So one way is like we of course need to know like how the direction is getting changed each time when we see a -1 or a -2. We also need to see like where we are currently standing, because if we are at north, then we have to change our y direction, add basically plus y direction. If we are facing east, then that means we need to increase our x direction. If it's south, we need to decrease. If it is west, we need to decrease the x direction. So we always need to know what are the directions or where the robot is currently. We also need to know where is the current obstacle. So we can in a brute force way, we can just simulate whatever the problem has provided. Like we can just start from 0 0, then we can see each of the we can see each of the command, and while we are increasing or moving, we need to go through all the obstacles and see if the current position or whatever the position that we are moving on is an obstacle or not. If it is an obstacle, then we need to stop. We should not move forward and we just need to stop. So that is the brute force approach. So if we go with the brute force approach, we of course need to traverse through each and every command, which will be a big of n if I say the command's array length is n. Plus for each of this command, we need to go through all the obstacles, because each time when we move one by one steps, then we need to move the obstacles. So in total, like it will be like a big of the length of command into we can move like the k is 9, so it will be a 9 times then whatever be the obstacles length. So if we check the constraint, the command's length is 10 raised to 4. This is around 10 raised to 4, and we can have this obstacles length as well, 10 raised to 4, and yeah, so this will be almost 10 raised to 8, and if we do a big of n square kind of time complexity, it will almost get time limit exceeded. So we need to somehow reduce some of our things that we are doing extra. So the main thing that we are doing extra is like for each command, we are going through each of these obstacles and seeing whether the current position is an obstacle or not. So if somehow we can store this in kind of a fast lookup data structure, then it will be a big advantage for us, because we can just remove this extra obstacles length time complexity by making a compromise to the space complexity. We will need obstacles length space complexity for sure to have that data structure. So the main thing, whenever we say about the fast lookups, the main data structure that will come to our mind is a hash set or a hash map. So here we are not mainly tracking any count or not, count or any other frequency or anything. We just need to see whether there is an obstacle. So for that, we can just make use of a set of string, and we can just store the 00 as a in the form of a string, something like $0 in the form of a string. And when we are just traversing through each and every point, we can just see whether that point is currently in this hash set or not, so that we can have a fast lookup. So that is the idea that we'll be mainly trying to implement. So let's try to start with the base cases. Even though like the problem says it starts like it won't be empty and starts with a valid length, it's always better to just for safety have a check from our end. It should not be null. If it is null, we can just return 0. Now let's have the commands length as commands dot length, the obstacles length as obstacles dot length. Now first step, we can store the obstacles in a hash set in string format. So let's do that. So set of string obstacle set equal to fill obstacle set. Let's make use of helper function that will just traverse through this obstacles array, and will just store it in the hash set. So it will be just returning a set of string fill obstacle set, and we will just pass the obstacles. So let's have this set of string is equal to new hash set as the data structure, and we need to return this obstacle set at the end of this method. Now we are just traversing through each and every obstacle and just storing it inside this obstacle set. So let's say obstacle set dot add of obstacle of 0 plus, we can do a string concatenation, even though like we can also make use of a string builder. Let's for this video, I'm just making use of the string appending, like the concatenation. It will have its own problems, but we can just for this problem we can go with this. So obstacle of 1. So now we have the hash set populated. Now like we are moving in different direction, like if it's for north, then we are moving our y. If it is for east, then we are moving our x. If it is south, then we are moving our y in negative direction. If it is west, we are moving our x in the negative direction. So maybe like we can have a constant direction is equal to new int of, so 0, 1, this can be for the y direction, 1 comma 0, this can be for the plus x direction. Then we have 0 comma minus 1 for the south and minus 1 comma 0 for the west direction. Now let's have our x, or let's say initial x, which is 0, or it will be like the moving x is equal to 0, moving y is equal to 0, and we are starting from the x direction, so our direction will be 0, like we are moving starting from the north direction, which is for y. So let's denote 0 as our north, 1 as our south or east, 2 as our south, and 3 as our west. So we can easily find we can make use of a trick. So if it says we need to move left, that means suppose like say we are here, if we need to move to the left, it's same as we are moving 3 times to the right. So whenever we see a minus 2, it means like we need to turn 90-degree left. It's same as whatever be the direction, just increase it to 3, and we are just dealing with 4 directions, just make it a 4. So suppose like we are at 0 denotes north, as I suggested, 0 denotes north. So if I see a minus 2 in my command, I can just do whatever the direction, 0 plus 3, that will give me 3 mod 4 is 3, which is of direction west, so we will automatically reaches this west direction. Same way, if I see a minus 1, I can just do a plus, that is whatever the direction, I can just do a d plus 1 and mod 4. So that's one kind of a hack that we can make use while solving this problem. Now we can just go through each and every command, and we can see what our command is. If the command is minus 2, then our x will be, our direction will be changed as direction is equal to, because we are not moving, like we are not changing our x or y, we are just shifting our direction. So if the command is minus 2, it's turn left 90-degree, which is as same as d plus 3 mod 4. So direction plus 3 mod 4. Same way, if our command is minus 1, it's just direction is equal to direction plus 1 mod 4. Now comes the part where we need to actually make the move. So for that, it's actually said we need to make it one by one, not just a jump. We need to move 1 unit at a time. So we need to go through each and every unit. So int move equal to 0, move less than the command, whatever the command that we have, move plus plus. So our next x will be whatever be our current moving x plus direction of what is our direction, 0 0, and our next y will be moving y plus direction of direction 1. So now we will see like we will be moving in the direction maybe plus 1 number of times or minus 1 number of times based on whatever the direction array that we have created here. So if it is the north, then we will move our y one up or one up. Yeah, correct. If it is east, then we will move our x one to the right. If it is south, we move down one, and if it is west, then we move left once. So that is easily handled here. Now we need to make sure that this is not an obstacle. So we already have our fast lookup obstacle set, hash set, which comes into help here. So we can just check if our obstacle set does not contains, or let's build string current moving is equal to next x plus dollar plus next y. So if not the obstacle set dot contains of current moving, that means we can make the move. So we can just move to the new x or the next x, and we can move to the next y, and we can just calculate the square distance, which will be moving x into moving x plus moving y into moving y. So I just forgot to have a variable to track our results. So our int max distance, let it be 0, or let's have a very small value, and now we can just compare with our max distance. So max distance equal to mat dot max of max distance comma current square distance. So this is the case when there is no obstacle. So if the next x next y string, the current moving string, is inside the hash set, that means it's a obstacle. We can't move forward. We need to stop in whichever the move x or move y we are in. So we can just say break. We don't want to continue and go on execute the complete command. We can just stop just before the obstacle. Now finally we can just return our max distance. So here we are having a big of obstacles length to populate the obstacle set. Then we have a big of command length here, and we are having a move, whatever the command. So here it's already given our move will be in between 1 to 9. So it will be like a big of 9 time complexity. So in total it will be big of obstacles length plus big of command length. And space complexity, we are storing all the obstacles inside an obstacle set for the fast lookup. So we are making a trade-off in that scenario, the space complexity. So it will be big of obstacles length for the space complexity. So time complexity is big of obstacles length plus big of command length, and space complexity will be big of obstacles length. So let's try to submit the problem and see if there is any error. So it's currently the initial set of test cases are passing. Let's submit the problem, and we have an answer. I think, yeah, I need to have it as 0. Maybe that's the scenario. Let me submit for this test case. Okay, now it's passing. Okay, so this is the solution for the walking robot simulation. Thank you.